I want to tell you a little bit about a special circle. What's so special about this circle? Well, it's pretty simple. It has a radius of 1. And you might wonder, well, 1 what? Well, it doesn't matter whether it's an inch or a foot or a meter. Its radius is 1. And using our handy formulas for circumference is 2 times pi times the radius. We can actually determine how far it is to go around this circle. Just go 2 pi times 1. So the circumference of our circle here, the circumference all the way around is 2 pi. And that can be useful in some cases. What if I had a larger circle, say like a tire, and it's had a radius of, say, 8 inches. Now I've got a unit here, but all I've got to do is it's 8 times bigger than that, so I just multiply by 8, and 2 times 8 is 16, so 16 pi inches. And, practically speaking, you'd multiply pi out and you'd find out what that is as a decimal, and that's how far it is around. And in this case, when that, in the case of this wheel, as it spins 1 times around, that's how far you would go, 16 times pi. And so there are plenty of applications for rotating circles called wheels, and and a bunch of other things as well, gears and propeller blades and all sorts of other things that have rotation where a spin corresponds to a distance. And we can scale it up and we can scale it down, and we can even actually look at, well, what would happen if I went not around 1 time, but maybe a quarter turn or 3.5 turns or anything like that. And we can do that fairly simply. So if I wanted to, for example, only go a quarter turn here, which I'm going to try to draw a right angle. It's not perfect. Well, I just take that 2 pi. If I'm in this circle here, just in this unit circle, we'll just stay there for now. I just take my circumference and I divide it by 4. And if I reduce that, I get an arc length. That's what we call it when we don't go all the way around here. If I reduce 2 over 4, I get the arc length here is pi over 2. And so there we go. We have the length a quarter way around a unit circle. And so while this is great and all, we usually talk about this angle here as being 90 degrees, and there's a big problem with that, is that when we want to do something with that 90 degrees, we always have to convert it into something else. As we just said, we want to relate this rotation, this distance that we traveled, with an angle. And right now, this 90 degrees relates to that pi over 2 in a unit circle. However, if we were to, say, try to solve this equation is somewhat simple. I mean, it looks simple. It's actually kind of more difficult to solve for a number of reasons. But one is this right here must be an angle. The sine is always of some angle in a right triangle. But the answer of a sine question is always a ratio of 2 sides. Meaning, if this equation were to have a real legitimate answer, this angle and these side lengths would actually need to be part of something that I don't need to convert. It can't be in degrees. And so to do that, we've come up with a system that has to do with the property of this special circle. So let me erase what I've got here, and let's start over with this circle. Okay. So remember, this circle has a circumference of 2 pi and a radius of 1. So that's the key parts about our circle here. And let me go ahead and use this circle and create a grid, an XY grid. Come on, there we go. Okay, let's rotate that. Try to pick it about halfway, so we're doing the diameter. And there we go. So I've got essentially an XY grid. And if this distance right here is 1, then this coordinate point right here at the end must be 1, 0, and the coordinate point up here at the top must be 0, 1. And if I go to the left over here, I must be at negative 1, 0. And if I go to the bottom, I must be at 0, negative 1. And the question is, well, let's start relating rotation with the distance that we've been going around. So if I look at this here, and let me use a different color. Let's go with green. This is 0 degrees. And if I go up to the top, I've rotated 90 degrees. And if I continue in that direction and rotate some more, I end up rotating a whole 180 degrees, or going the opposite direction. If I keep that path, that rotating from the 0 to the 90 to the 180 all the way to the bottom, I'm at 270 degrees. And if I come back here to where I started, I'm at 360 degrees. Well, we're going to use this property of our circle, that one trip around is 2 pi of this special circle. Or if you don't go anywhere, it'd be 0. And we're going to use that fact to talk about the distance that we've traveled along this circle as we go. We've already said that 90 degrees is a quarter of the way, so we take 2 pi and divide it by 4, which we showed was pi over 2. So 90 degrees, we could talk about it that as degree rotation, or we could talk about it as a rotation, as a distance traveled in this rotation of pi over 2. If we go all the way halfway, well, what's half of 2 pi? It's pi. And right here, I need to pause. This is a very critical thing to remember, that in our unit conversions, 180 degrees and pi radians are equivalent. And we'll get into this more later, but this is our sort of definition, that pi radians and 180 degrees are equivalent. Now, if we go down to the bottom and continue this pattern, we're going to get 3 pi over 2, because the top is half a pi, and then we get another half, and we get a whole pi here at 180 degrees, and when we go to the bottom, it's 1.5 or 3 halves pi. So that's great. So that's where 90 degrees falls in. But what about all these in-between angles? I mean, we've got angles here that are halfway that are 45 degrees. Halfway here would be 135 degrees. Halfway down in this third quadrant would be 225 degrees. Halfway down over here is 315. Okay, what are those in radians? Well, what's half of a half? 90 degrees is pi over 2, so it's half of pi. Well, half of a half is a quarter, so that means that this is a quarter of pi, or pi over 4. And as actually we go around, you're going to see that all of these things that are halfway are over 4. And part of my goal with this and showing you all this is these are common angles that are going to come up a lot, and I want to kind of have you get a sense of where they fall on this unit circle. These are very common angles that you're going to find in any trigonometry course, and they help us sort of wrestle with a bunch of different concepts in geometry, and also as well as what we're talking about right now, what radians are. So I'm going to fill this in, and basically there's going to be 30 degrees, 45, 60 degrees, and 90 degrees. Those are our common angles. And then I'm just going to add that 30 from there, do that same pattern. So 30 degrees from 90 is 120, 45 degrees from 90 is 135, 60 degrees from 90 is 150, and 90 degrees from 90 is 180, and just continue that pattern. So 210. 225 and 240. So once after I get to 270, 300, 315, and 330. So these are our key points along a unit circle. And I'm going to show you how this works out in radians. So 30 degrees is 1/6 of 180. So this ends up being pi over 6, because 180 degrees is same as pi radians, which ends up meaning that all of these ones that are just 30 degrees from the horizontal end up being over 6. So this one's 5 pi over 6, 150 degrees. If I go down just 30 degrees from the horizontal, it's 7 pi over 6. And then all the way over here on the other side at 330 degrees, I'm 11 pi over 6. So all those ones are over 6. So if you see something over 6, it means that we're going to be somewhere near that horizontal, either just above or below. If you see over 4, it means we're at one of those halfway points, those 45-degree halfway points in the quadrant. And then lastly, what about these ones at the top here? Well, I've got pi over 3 because 60 degrees is a third of 180. This one over at 120 is 2 pi over 3. Down at the bottom here, I've got 4 pi over 3. And here I've got 5 pi over 3. And you might wonder, well, I've got 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Well, what happened to 3 pi over 3? Well, 3 pi divided by 3 is just pi, and so that's 180 degrees. So that's why some of these things will skip. But as you can see, the ones that are 30 degrees from the vertical are all pi over 3. And so I just want to give you a chance to kind of observe these sort of common things that we're going to see. When you look to Teams and download the unit circle, you're going to see all these angles written. But then in the next video, we're going to look at just doing the straight conversion, the sort of algebraic conversion between radians and degrees and vice versa. But here are all the key and important places upon a unit circle, and we'll talk about how you use that unit circle in a following video.